welcome back. If you have missed some of our videos, please go to the channel, click watch and subscribe. Today's topic is differentiation of inverse trigonometry. So we'll be talking about differentiation of inverse trigonometry function. We'll be talking about differentiation of inverse trigonometric functions. Now, the first one we are going to look at is first one, we're going to look at sine inverse of x. Number two, we look at cos inverse of x, how to differentiate them. Okay, so watch closely if you have missed our video or other ones. Now, number one, given that y equals to sine inverse of x, we want to differentiate, we want to find dy dx on this function. Then, but before we do that, remember what I told you before. If you have sine inverse of 0.5, it gives us 30. If sine inverse of 0.5 gives us 30, this is just like sine inverse of x. Here is x, gives us 30. Here is 30, which is y. Then it then means that sine 30, no longer sine inverse, will give us 0.5. Then if you understand that idea, this means that since sine inverse of x gives us y, okay, let's put it this way so you understand it clearly. If sine inverse of x gives us y, it then means that sine y will give us x. I don't know if you understand what I did there. If sine inverse of x gives us y, it then means that sine y will give us x. Okay? Then from here, we differentiate left hand side implicitly. We differentiate left hand side implicitly. How do I do that? To differentiate an implicit function, when you differentiate, you multiply by the derivative. So we have that differentiate this, we have cos y dy dx, because of y is not a function of x here. It's supposed to differentiate x, we have 1. Okay? So to find dy dx, which is this, is now equals to 1 all over cos y. Okay? Now we are supposed to stop here because this is dy dx, but the right hand side is not in terms of x. Anytime you differentiate with respect to x, your answer will be in terms of x. So because here is still in terms of y, we are now going to do some logistic using trigonometric identities in order to convert this to be in terms of x. How can we achieve that? We are going to recall that sine square x sine square y plus cos square y is equals to 1. So this implies that cos square y is equals to 1 minus sine square y. Okay? So from here, cos y, which is this, is equals to the square root of 1 minus sine square y. So do you see how we have achieved that? So any place you see this, you put it sine square root of this. So from here, we now go up. So from this relationship, we now have that dy dx is equals to 1 all over my cos y. I have gotten it to the square root of 1 over square root of 1 minus sine square y. Okay? Understand what I did here? So now look at the relationship. I still have y here. So I will fall back to this place. Watch this place. I have that sine y is equals to x, and here is sine square x, sine square y. So I will now write that dy dx equals to 1 all over the square root of 1 minus sine y is equals to x, and it is squared here, so it will be x squared. This becomes the derivative for sine inverse of what? Y. So let's look at cos inverse of y. They are just the same thing. Let's look at number 2. Number 2 is cos inverse of x equals to y. So we do the same thing. This implies that cos x implies that cos y is equals to x. Okay? Differentiate this. We have minus sine y dy dx. We multiply by dy dx because this is implicit. It's not a function of x. So we'll differentiate this, we have 1. The same thing is applicable. Divide. We have that dy dx is equals to minus 1 all over sine y. Okay? So we are supposed to stop here because this is dy dx, but here the right hand side is not a function of x. So we use the same trig identity to convert this thing in terms of what? X. Now, from here, what we have is, okay, from that identity, we have that sine square y plus cos square y equals to 1. This implies that cos square y is equals to 1. Sorry, we are looking for sine square this time around. This implies that sine square y is equals to 1 minus cos square y. This implies that sine y is equals to the square root of 1 minus cos square y. So we have gotten everything we need. So what we have now is that dy dx from here is now equals to minus 1 all over square root of 1 minus cos square y. Okay? This thing becomes this one. So from here, dy dx is equals to minus 1 all over. Go back to this place. What is cos y is x. So in case you see cos y equals x equals the square root of 1 minus x squared. This becomes the derivative of cos square y.